Hello, friends. This is David Pine with a deep dive in the Cosmos DB repository pattern.NET SDK. I'm the host of the .NET Doc Show. Just a little bit about myself. I work in DevRel at Microsoft. You can follow me on Twitter at DavidPine7. All of the source code you're going to see today is available on GitHub at my handle iEvangelist. And if you're interested, you can check out my blog. I maintain a blog at davidpine.net. So when we think of the repository pattern, it's really as simple as basic CRUD. So create, read, update, and delete. Those are the primary actions that you really want to take when interacting with simple objects. So the repository pattern that I've built is essentially a wrapper around the existing Azure .NET SDK for Cosmos DB. And I call it a modern API because it's embracing the repository pattern. It's based on generics. It's asynchronous. It supports cancellation. It has support for partitioning through attributes and overloads. There's additionally overloads for expression-based SQL, strings, and query definitions as well for all the various things that you might be interested in doing with your items. All of the source code for this is available in the open. It's up on GitHub, so go to aka.ms Cosmos DB github.net-repo-pattern-SDK. And the bulk of this talk is actually going to be in the demo itself. So I like looking at source code, so we're going to jump over to some source code. I have the repository open here, and it's, as I mentioned, it's essentially just a wrapper around the existing official Microsoft.Azure.Cosmos.NET SDK. And what it does is it provides a few abstractions. The primary abstraction is the IRepository. So this is an interface that defines our create, read, update, and delete functionality. So from the repository, you can see that implementations of this are constrained to the generic T item type. So where T item type is an I item. So there's an interface that you're bound to use, that you're required to use when you're using this interface. So you'll have various IRepositories. So imagine you have an object that represents a person. That person object would have to be a subclass and implementing I item. So you can get, so this is the read. You can get things by ID. You can provide partition key values. It supports cancellation. These are all asynchronous. You have the ability to get by query. So these are the SQL strings. You can get by query definition. You can get by expressions, creating all the various create, read, update, and delete functionality that you'd expect from the repository pattern. So there is a default implementation of this that's provided for you. So out of the box, you can expect that you'll have your default repository implementation available when you're consuming this library. So by default, it expects a few different things. It takes an iOptions monitor, and this is some of the dependency injection nomenclature that's available from .NET Core. And what this allows is for our repository options to be dynamically updated as changes to their actual configuration values are altered. So because this is sitting on top of .NET Standard 2.0, you get all of the cross-platform capabilities that you'd expect. So it runs on .NET Core 3.1, which is the current LTS release of .NET Core. It also runs on .NET 5, which is the current, but no plans for LTS with that one. So wait till November for .NET 6 and .NET Framework. And as a result of that, you get all of these, you know, configuration, IOptions, pattern stuff available for you. It also requires a container provider. The container provider is really what resolves your individual container and your data store for your item. And then you get a logger. So the implementation is pretty straightforward. Again, it's an abstraction over the existing SDK. So when we're getting an item by its ID, we could provide a partition key and a cancellation token, and the container provider gets a container asynchronously. And since we're good Samaritans of async and await, and we're libraries, we're going to make sure that we are configuring await to false. If you're unfamiliar with this, this is specific to the synchronization context issues that exist with async and await. So it's best to say that you're not worried about continuing on the captured context. So once we resolve our container, that's where we can walk up to the reading of this item. So in the official Azure Cosmos DB .NET SDK, this is the type that we're kind of abstracting over. So the provider itself will ensure that the container is configured and initialized, and if it doesn't exist, it will create it for you. Likewise, it'll also create the backing data store and database, and all of those things are kind of managed implicitly. And then once you have the container instance in context, that's when we can actually read the item out. So avoiding some of this API and some of this repetitive boilerplate code, all you have to do is take on a dependency of IRepository for your type and say get async of that type given the ID, and all of this implementation is managed implicitly. So then once you await your response, you'll have a resource. That resource does represent the generic type that you've specified for your object of the repository. And then there's a bit of logging that occurs on your behalf if things are set up to debug. We'll debug the serialized version of that object and write it out to the console if in debug mode, so you can see what your objects look like, the entire object graph. And that pattern is pretty much repeated for all of the various overloads of reading. So you can get a list given an expression, which is basically it's a predicate. So rather than being a simple function delegate, it's an expression of a function. So expressions can be compiled. And what's really interesting about those is they can be compiled, and then that's what's passed over the wire and then executed on the server. So rather than a function, they act a lot like functions, but we can compose them and wrap them together and make very, very expressive syntax to kind of define our queries using link and stuff like that. So this is one of my favorite things about this abstraction. The nice thing is too, expressions, when you toString them, you get the actual SQL syntax for them. So in debugging this application, the demo app I'm going to show, you'll get to see in the console itself the actual SQL-esque type queries that are passed to Cosmos DB from these expressions. So then when we have an Ionnumerable of these things that we're trying to read, we would require a query feed iterator. So we're going to use the feed iterator, and while it has more results, we're going to read those asynchronously and add them to our collection that we're going to be returning. So again, all of this code here, if you're using the SDK, except for some of the logging stuff, would be essentially required, and it ends up getting pretty repetitive. So instead, you can just say you want all of the items that match this given predicate, and this happens for you. Kind of, you can take it for granted, right? The same is true for all of these other loads, overloads. So by query definition, and then when you're creating it, again, you're going to require a container, and then you're going to walk up to the container and say create item async, given the value, given the partition key, and the cancellation token. And then you can create a list of those. So this one just iterates out, and it supports a degree of parallelism. So you can essentially fan out and do all of these things concurrently. So this create task, given all of these individual items, will span out and do essentially multiple calls into Cosmos, updating or inserting rather all of these different items. When you need to update an item, simply give the instance into the update function. And then from that, we'll call upsert. Upsert is an interesting play on words where you're updating an item or inserting it if it doesn't already exist. And then obviously any of your delete scenarios where you need to delete items. So you can delete them by ID, by the actual item itself, or additionally with partition keys and things of that nature. So let's go to the repository factory. So I created a factory abstraction as well. So there might be times where you require multiple IRepository instances. So what this allows you to do is you require the repository factory, and then you can say a repository of a given type. And then this is a good way to get multiple versions of different repositories. So again, all of these abstractions exist to kind of serve as a convenience for the creating, the reading, the updating, and the deleting, all of the primary things that you might be concerned with. So the repository has several different options. So there's a connection string. This is the primary or secondary connection strings that come from the Azure portal. The database ID and the container ID, these are defaulted to database and container. Obviously, they're overridable because they're configuration options. Likewise, we have an option to optimize the bandwidth. So under the covers, there's an item request options, enable content response on write. This option is set for you to default on your behalf to take advantage of optimizing bandwidth where possible. You can configure it to false if you'd like. Additionally, we have the ability to have a container per item type. And this defaults to false. So what this really does is per container that exists within Cosmos DB, you could have, if this is true, you would have a single container per type of item. So in C#, when you have a subclass that is implementing the item or the I item, or an implementation of, or a subclass rather of item, you could specify that you want to have an individual container per item of that type. Otherwise, you could have the container basically conjoin all the different types. And it really doesn't matter because there's this concept of discriminated union. So it's really a preference of your team, how your team wants to manage your different data stores. If you prefer having an individual container per data type, or if you're fine with having multiple items per container type. Additionally, we have allow bulk execution. So all of these different settings are configurable. They're available to you as the consumer of this library to specify. And then there's additional considerations with partition keys. So you can specify, out of the box, the repository pattern.NET SDK is going to make some choices for you, but you can configure it to your liking. So by default, the /ID is used as the partition key on an item, and an item has an ID, which is a string, and it has a type. This is the discriminator, and it has a partition key. So the partition key value has a default implementation that exists. So we have an abstract class of item, which is implementing the item interface. We've got a JSON property of ID, which is essentially set to a new GUID stringified. We have the type, and then we have the partition key value, and then the type is set to the type of the subclass. And then the availability to specify the partition key value is virtual. So you can override this. So what that means is subclasses who opt into having a partition key path attribute defined, they can also override the get partition key value to specify a conjoined or composite partition key if they want to specify more things than just the ID. But we default to ID. So it's really as flexible as you want it to be. So I'm going to encourage you to spend some time looking through some of these other options. One additional thing I'd like to call attention to is out of the box, there is some extensions, service collection extensions specifically. So it plays nicely with ASP.NET Core, .NET Core, all of the dependency injection and wiring. It's following all the very common nomenclatures and naming conventions there. So there's an extension method on the iService collection. So you have services, you'll walk up to those services and you'll say add Cosmos repository. And then you have the ability to specify a setup action, which takes the repository options and does some stuff with them, some mutations on them. Internally, this is going to set up logging and the HTTP client. It's going to register all of the singletons for dependency injection. And what this means is when you're using ASP.NET Core, for example, or any of the .NET Core bits for dependency injection, you can require in your constructors or on your controller action endpoints, using the from services attribute, you can require an IRepository of the type. So if you have a foo, for example, you can say IRepository of foo. And since this is generic, you'll get a one-to-one mapping. So there's only ever one default repository implementation for your generic type that you specify. So I'm going to show you what that looks like, actually. So we're going to minimize this. We do have a samples repo, or directory rather, and we've got Azure functions highlighted. We have service tier, so like imagine like a background service, or we have the web. Whoops, that's not what I wanted to open. Or we have a web tier. So in the web tier, we have our startup, and the startup. This is basically following the file new project template for a web application. So when you do that, you end up with a program file and you get a main entry point. You're configuring your host builder and it runs and it specifies a startup file. The startup file has two primary methods on it, the configure services and configure. So in configure services, this is where you'll use that extension method from the library. So you're going to say services, add Cosmos repository. So the Cosmos repository then registers all of the services required for it to do its thing. Additionally, I'm adding Swagger to kind of demonstrate the web API aspect of this. But that's it. Once you have created your Azure resource for Cosmos DB, and you have configured environment variables or however you want to specify these options. You can do it with user secrets. You can do it with Azure Key Vault. You can do it. I'm using environment variables. But all of these options are configured and they're picked up implicitly. And now we can go ask for, through dependency injection, for implementations. So what I'm going to say here is let's go to the models first. So we have a programming model called language, and language is a subclass of item, and item is the item, the default implementation of item, iitem, the interface from our library. So since we have that subclass, we get a few things already out of the box from this. We get an ID, we get a type, and we get the ability to override or specify new default behavior for partition keys if we'd like. So we're going to add a couple other properties. We have a name, we have a string array of aliases, we have a string description, we have a programming style. So this is just an enum that I've specified over here. And then we have an initial release date. So it's a simple object. And that's what I really wanted to kind of differentiate, is that for simple objects, object graphs that aren't super verbose or complex, or there's not a need for explicit relationships and things of that nature, this is a great solution for requiring a simple repository. So in our language controller, this is using ASP.NET Core's Web API. So we have an API for our route, and then the controller, which is language. In our constructor, we're actually requiring the IRepository factory. So from this factory, we can say we would like a repository of language. So that's going to give us an IRepository of language. So with this repository instance that's been provided for us from dependency injection, we can walk up to it and say repository get all the languages where the initial release date were greater than this expression, or get a language by an ID, or create a language given from the body of this HTTP post. So we're basically matching HTTP verbs here for our web API with a backing data store that is a wrapper around the Cosmos DB existing .NET SDK. So we can do all of these creates, the reads, the updates, and the deletes. And this is 43 lines of code. So we have our language model, we have our controller, we've specified our startup, and then if we run this, I hit run, we'll see what that looks like. I'm gonna move this window over here a bit, wait for it to start up. Admittedly, the first time that it does have to make the initial call out to Cosmos, it does take a bit, because the container has a bit of logic in there that it verifies that the container exists, it verifies that the database exists, and it's basically calling create functionality if those are unavailable. So I'm going to bring this over here. This is the Swagger page, which is absolutely beautifully done. And this is not a UI I wrote, but simply since I chose to use Swagger and I defined my web API endpoints, all of this came kind of out of the box, which is beautiful. So I'm going to zoom in a bit on the text of the console. We're going to go back over to our Swagger page. Just going to do a get, try it out, hit execute. It's going to load our repository information. Error, failed to fetch. Well, that is not what I was expecting. It worked before, I promise you. Wait for it. All right, give me, oh, fun. We're gonna try that one more time. So this was working, so hopefully it works. So we're going to do a get, we're going to hit try, we're going to hit execute. It's loading. Ta-da, okay, now it worked. I don't know why it didn't work the first time. I do apologize for that. But as you can see, we have two languages that exist in our data store right now. We've got C# and we've got JavaScript. Of course, those are probably two of the most popular ones to date. But from this, you can see that we can post a new language. We can put, which is essentially an update. We can get an individual one. So let's just grab the ID of JavaScript, copy that. Go over to get, we're going to try that out. We're going to paste in the ID, we're going to execute it, and we should get an individual, and you'll notice how much faster it is now, once it's kind of made those initial calls out to the container and has all that stuff kind of in memory, so to speak. So subsequent calls are a lot more efficient. So we have our get by ID. Let's create a new one here. So we're going to try it out. We're going to get rid of ID since we know that is done for us. We're going to get rid of type since we know that's done for us. The name, funky lang, alias, we're going to say SFL, description, a demo language lang for our viewers. And yeah, we'll call it functional. We'll say it was created today. We're going to execute that. We get a response back. So now it's there. So now we have an ID, right? This ID was returned from the call to that. So it's showing you that, hey, it's created. Also, there's an ID for it. So now if we go back out here and we call the, let's minimize this one. If we call the get with this ID, we should get our funky lang, right? So now we've created it. Let's update it. Let's call it something else, right? Actually, why don't we just delete it? Let's delete it because that's a terrible language. Not everyone's super excited about our new funky lang. So execute. Now it's gone, success. So if we go back up here and we read everything, we should get just the two that we had originally started with, right? And that's all happening very, very rapidly from our very simple controller. So it's literally as easy as adding a new model and a new controller that just basically decorates using, right? This is essentially the decorator pattern. So we have our controller endpoints and we have our repository, and we express those as we see fit. And you're able to very, very rapidly build out functionality based on your POCOs, your plain old class objects. The same is true with another demo here. So if we just have like a service tier, for example, in this demo, we again have a host builder that will start, and then we're asking for our repository factory. And from our repository factory, we can demonstrate various functionalities. So we've got a person. This person actually identifies that they have a partition key path. So this is the attribute where we're able to specify our partition keys. And this is where things get a little bit more advanced. So from our partition keys, we can say that we have a / synthetic partition key. And that's our partition key property is mapped to this property here, which is a compound first and last name with a hyphen delimiter. And this isn't, best practice by all means. This is simply for demonstration purposes. Ideally, you would do something guaranteed more unique and better than first and last name. Again, this is just for demonstration purposes. And then you would override the get partition key value given the key value here. And then just like that, you have partitioning happening for your person container. In this case, we've configured to have a container per type, whereas the language one was I could go into the web app and have I could start adding different models, and those models would then just continue to add to the same container. In this case, we end up having a container for a person, and we also have a container for our widgets. So widgets have a name, they have a created or updated on, and in our program, we have, well, let's look at our example service. So we have a service that knows about persons, and that's pretty much it. This one just worries about people. And its implementation is, again, using the decorator pattern. It's almost like it's not needed at this point. You could simply just use the repository instead. But if you were implementing any type of business logic or business rules, and you had try catch in the service tier, you're logging errors or anything of that nature. That's typically where you would try to encapsulate this. But our program essentially starts by registering, when it's building out our host, it's going to register Cosmos DB. And this one's using the overload. So rather than using the implicit options, we're actually using the overload that takes options and lets you configure them. So you can walk up to the container ID. You can say we have a people store. We have a database of samples. We optimize the bandwidth. We do a container per type. And then we also register our example service. And then we show that you can create new people. You can read them. You can update them, delete them. Same thing with widgets. And it's all pretty straightforward. And that's what I really like about the repository pattern is it lets you as the developer focus less on boilerplate code. It lets you build out your models that you care about and your business rules around them, and then have a reliable data store that is, Cosmos DB. So hopefully this has been something that's exciting. I'm trying to think if there's any other parts of this specifically that I should show off. Since it is a deep dive, there are a few things that are kind of interesting. So let me pull this up here. So we have, if you recall, we do have the container capability. So we have the iCosmos container provider. This is generic to an individual item. So it's also constrained to implementations of an item. And when it's created, the container provider has several different things. It requires a Cosmos client provider, the Cosmos partition key path provider. There's a logger that takes on the repository options. And then it has a lazy task that represents the container. Since we're isolating these and they're scoped to singletons, and they're in the context of your application as a library reference, they're in memory, so to speak, with dependency injection. So we can do things like lazy tasks. So once we resolve the container, we can hold on to it and then just return it back to you very, very quickly. Some of the logic that exists and some of the boilerplate code that was a concern years ago for me. Initially, when I started building this out, I started with actually the document DB versions and have since moved to keeping up with the latest. So some of the things I noticed, though, was the fact that when you have to start things off, you have to basically get a client, you have to create a database if it doesn't already exist. And then once you have a database, then you have to create a container for the database if it doesn't already exist. And a lot of that effort is can be repetitive. So this library really aims to encapsulate all of that common stuff, still expose it as being configurable, and really allow you, the developer, to be more productive. So I'm going to switch over to this screen real quick. I mentioned I've been working on this for a while. This was one of the initial versions from 4 years ago, and it was following the same type of thing. So this is iEvangelist document DB. This is back when that was around. And the idea hasn't changed much, right? So we've got an IRepository of T. At that point, they were called documents because it was document DB. Now they're items. So instead of a base document, we have item and items. And it's simply create, read, update, and delete. And then for those who are interested, this is open source. If you would like to participate, if you'd like to propose new features, if you'd like to partake in looking more into how it's implemented, by all means, check it out. I'm pretty active on here. And if you do contribute, whether it's a feature, an idea, a bug, or anything of that nature, I'll add you as a contributor. And we've had some friends already applying updates and suggestions, and this thing's evolving quite a bit. So I'm excited for the future of it, and I'm very hopeful that you find it useful. So I'm going to go back over here to this, and we are going to say that here are the additional resources. So You can go to aka.ms/cosmosdb/NuGet/repo pattern SDK. That is the NuGet package for the SDK. We also have a entity framework stand-up that I was a part of. This is a link for that, where I shared, it was basically a 2-hour deep dive at that point in time, where I actually met with some of the architects and developers of the entity framework implementation of the Cosmos provider, and they picked it apart, and we had a great conversation there. The GitHub repo and a blog post where we announced this last year. So with that, thank you all so much, and hopefully you've enjoyed this talk.